Multiplying polynomials. What is important to remember when we multiply polynomials? Well, first we need to remember about the distributive property. If we take 3a and multiply it times 6b, we'll get 18a and b. And we have to remember that not we just only multiply to the first term, but we have to multiply to the second term as well. So 3 times 7 is a positive 21, and then an a comes with us. We notice that we're multiplying numbers and collecting variables. Now, if we put this in an order that we can think about as steps, remember when we multiply a polynomial by a monomial, distribute the monomial to each term. With the numbers, we're going to multiply those together, and the variables with like variables. In other words, we're just going to add the exponents. So let's take a look at a few problems to see if we can practice these steps. So first off, here we have 2x times 3x squared plus x plus 4. If we distribute the 2x to every single term, our results will be 2 times 3 is 6. I have 1x here and 2 more there, giving me x to the third. 2 times 1 is 2, and I have 2 x's here, so that will give me x squared. And 2 times 4 is 8, and I have a single x which comes along with me. Let's take a look at another one here. Let's do it again. We're going to give a 3a squared out to negative 5a to the third plus 2a minus 7. When we do that, we get 3 times negative 5, which is negative 15. Add our a's together, which would give us 5. 3 times 2 is 6. Altogether, we have 2 a's and 1 more a, giving us 3 a's. And 3 times negative 7 is negative 21, and the a squared comes with us. Now, when we multiply binomials, there are 3 different methods we can choose from. So we're going to take a look at each method separately. First off, we're going to look at what we call the distribute and stack method, one of my favorites. And what we're going to do is we're going to use our hand or our finger to help us to do that. So what we're going to do is we're going to cover up one of the terms of the binomial. So it looks like a monomial multiplying a binomial, just like we had a second ago. And we're going to give that x out to both of these. So x times x is x squared, and x times 7 is 7x. Then what we're going to do is we're going to move our finger over and cover up the first term. So now we have that monomial here. We'll give that 3 out to the binomial x plus 7. 3 times x is 3x, and we're going to line it up underneath the 7x because that's what matches, and 3 times 7 is 21. When we add all this together, we're going to get x squared plus 10x plus 21. So this is the distribute and stack method. I'm going to use the same binomials over and over to show you all 3 methods. Here's the second method, which is probably really famous to most people. It's called the FOIL method, otherwise known as first, outside, inside, last. And what do we mean by that? So when we talk about the first terms, we're talking about multiplying the first terms of the binomial. So we get x times x, which is x squared. Then we're going to talk about the outside terms. Multiply the 2 outside terms together, which would be x and 7. So x times 7 is 7x. Then what we do is we look at the inside terms. If those are the outside, these 2 are the inside. 3 times x is 3x. And then we would look at the last terms in the binomials, which would be 3 and 7, and 3 times 7 is 21. We would line them up like this, and we would look for like terms to collect. We can see that in the middle here, these 2 are alike. So we continue x squared plus 10x plus 21. Now in method number 3, it's called the box method. And here we're going to walk through our steps, and we're going to do it at the same time. Step 1 says write the binomials outside the box, including the signs. So here I have x plus 3, so I'm going to write x plus 3. And on the other side, I'm going to write x plus 7, bringing the signs with me. Second step, multiply the outer edges of the box to find the area. So this box here would have an area of x by x, which would give us x squared. This box here would have a measurement of 3 by x, because that's the other side there, and 3 times x is 3x. Here this one would be 7 times x, which is 7x, and this one over here would be 3 times 1, which is 21. Okay, so we've satisfied step 2. Now the last step, write down the terms inside the box and collect like terms. Now we can do this one of 2 ways. We can just write them as we see them, or as ones that are common to us, we can stack them and put them together. X squared plus 10x plus 21. I will tell you that typically when you do the box method, typically on the diagonal will be like terms. So you might be able to see it, x squared plus 10x plus 21. Now, different methods are useful at different times. We're going to try all three again one more time, give you an opportunity to try all three methods, and then you're going to find a method that works best for you, depending on the type of learner you are. So let's take a look at this one, x plus 3 times x minus 5, and we're going to use the distribute and stack method and use our finger to cover things up so that we can do it. So we're going to cover up the second term, and we're going to distribute that x out, just like that. And what we get x times x, which is x squared, and x times negative 5, which is negative 5x. Let's move our finger over, cover up the first term, and this time we're going to give the 3 out to both terms. 3 times x is a positive 3x, and 3 times negative 5 is negative 15. If we add these terms together, we'll get x squared minus 2x minus 15. Let's practice the FOIL method here. And here we have two binomials, 3x plus 2 times x plus 5. Let's take the first terms. So that would be 3x times x, which would be 3x squared. Then we're going to take the outside terms, which would be 3x and 5. So that would give us 15x. We're next going to take the inside terms, which are 2 and x. So that'll give me positive 2x. And then we'll take the last terms, which would be 2 and 5, which would be positive 10. We're going to collect like terms. Things that are alike are in the middle there. 3x squared plus 17x plus 10. Now we're going to try the box method. And we have two binomials that we're recording, 4ab plus 3 times 2a squared plus 1. So when we look at this with the box method, again, let's line everything up. So we're going to put 4ab plus 3. And again, it doesn't matter which side when it's a 2 by 2, which side we're going to put it on. And then we're going to multiply to find the area. So 4 times 2 is 8. We have 3 a's and 2 b's. 4ab times 1 is just 4ab. 3 times 2a squared b is 6a squared b. And 3 times 1 is 4. In this case, our diagonals are not the same. So what we're going to do is we're just going to write down all our terms because we're going to have 4 different terms this time. So 8a to the third b squared, and we're going to put them in order, descending order, 6a squared b plus 4ab plus 4. Now, what if the polynomial is larger than a binomial? Well, guess what? I would suggest using the distribute and stack method just because I think it keeps things straight. So let's do this one, 2x plus 3 times x squared plus 4x plus 5. And again, I'm going to put that binomial on the 2 side because it's 2 boxes wide, and it's 3 boxes long, x squared plus 4x plus 5. And we're going to multiply 2 times x squared is 2x to the third, 2 times 4 is 8, and x squared, 2 times 5 is 10, and x. Here we have 3 times x squared is 3x squared, 3 times 4 is 12x, and 3 times 5 is 15. Again, we're going to write down all our terms, 2x to the third plus 8x squared plus 10x. And I'm going to put down underneath them ones that are alike, 3x squared, extend my page a little bit, 3x squared plus 12x plus 15. And I'm going to add those up together. And I get 2x to the third plus 11x squared plus 22x plus 15. And again, here's that one about the diagonals. See, on the diagonals, we have the common terms. Okay, now let's talk about something specific, something called difference of squares. This is an important pattern to recognize. What that means is if I have two binomials where one is minus and the other is adding, if I was to distribute them, a times a is a squared, a times b is ab, negative b times a is negative ab, negative b times b is b squared, I'm going to find out that that's equal to a squared minus b squared. So whenever I see this pattern, all I have to do is take the first term and square it, take the second term and square it, and drop a minus sign between it. That's why it's called a difference of squares. This means difference. These two are squared. So if we looked at certain things, for example, we know like x squared, 4x squared, that's a square because that would be 2x. We know that 9x squared, 3x. 16, the square root of 16 is 4. We can take square roots of numbers and that we can see 100 is 10, 25 is 5, and we know that these are relative things and we can take a look at it. So let's take a look here. Here I have x minus 4 times x plus 4. If I follow that pattern, I know I can take the first term and square it, which is x squared. 4 times 4 is 16. Drop a minus sign between it. Take a look at another one here. Again, follow the pattern. They're identical binomials, except one is adding and one is subtracting. And you notice it doesn't matter the order they come in, which is first, which is adding, which is subtracting. It just matters that they're identical in terms in their spots. So 2x times 2x is 4x squared, and 5 times 5 is 25. And we're going to drop a minus sign between it. We'll take a look at one more problem. 3x minus 10 times 3x plus 10. And again, 3x times 3x is 9x squared, and 10 times 10 is 100, and we're going to drop a minus sign in between it. Hopefully that'll help you with multiplying your polynomials.